Salam all. On today's lecture, we are going to learn about the logic instructions. So this is going to be the bit manipulation sections. Okay, so this is a bit manipulation session. So I'm going to touch on these topics and this topic for the first half, and then the second one will be going to be covered on this one. Right. In these slides, for the BCD operations, I'm not going to touch it. So this is going to be skipped at the moment. Alright, so we are going to directly go to the Boolean instruction. Okay, let's look at this one. What is Boolean instructions over here? So logical group is used to perform AND, OR, exclusive OR, and NOT operand of the byte size, word size, or long word size contained in the register, or the memory, or the CCR, and the status register. So the instructions will be used like this, which is the AND immediate, OR immediate, exclusive OR immediate, and NOT. So total will be up to 7 syntax for this particular syntax boolean, right? And before we are going to the syntax, so we have to go back to the revision sections on the gates last time when you learned in your secondary school or in the first year. So we have learned about the AND gate, we have learned about the OR gate, we have learned about the exclusive OR gate, and we have learned about the NOT gate. Okay, and for this one, right, you see, can remember that, let's, for example, this is your input. Okay, this is your input A and input B. Okay, so you have in binary, it should be 1 or 0. So you have two inputs, and this will be your output. For the case of NOT here, for the case of AND here, OR is here, and exclusive OR is here. So NOT is very simple. Normally NOT will be only one inputs only, right? For example, here is A input, so the NOT for A will be 1 for 0. Very simple. You just need to put the opposite values of the NOT, the value from the first input. So if you have 1, you must have 0. And for the AND gate, it's very simple also. AND gate, for the AND gate, okay, for the AND gate, for the case of 0, 0, if you have any 0 in your AND gate, the result must be 0 here. But for the case of OR, if you have any 1 related to it, the result of the two inputs will be coming 1 over here. So this is actually a revision. And for the exclusive OR, this is maybe you just need to go back to the past topics about this one. So exclusive OR is about if you have the OR situations over here, the result must be 1, 1. Okay, so let's look at the example here. If you have 0, 0, your result will be 0. If you have 1, 1, your result will be 0 also. So these two results for 1, 1 is going to be a different numbers, which is your input must be different, like 0, 1 or 1, 0. So these are the cases for the operand, logic operand. This is for the Boolean instruction. This is operand for the NOT, and OR, and exclusive OR. Okay, let's move on the syntax. So what is logic AND? Okay, so logic AND just now, this is the one AND here. Okay, the AND here, this is the AND. Okay, so AND instruction will erase certain bit in the destination. Source operand acted as the mask which determine which is bit to be erased. So you have the source here, and you have the destination here. Okay, this one is going to be the mask, the number that you are going to do the operations to the destination. So the destination is going to be masked from the S, and if the value for the source over here, if the value for source is equivalent to 1, like for example just now, if you have 1, okay, you will keep the current bit value in the destination. So you look back over here, if you have a value of 1, and then you have the mask 1 over here, you will keep the value for it. So you got the answers. So if you have a value of 0, means that for n, anything you end with 0, you are going to erase the number, or you're going to have it 0 for the results. So the syntax will be very clear, which is the n dot what the size that you want to use, and this is your effective address and your data register, or vice versa. So you can see that this is the one, immediate size, destination, and destination. So this is immediate. Immediate is a bit different because you have to know that this is just the direct value compared to this one. This one is based on the last effective address that you want to use. Okay, let's move on. Now the question is, erase all bits in D0 except 0 to 3. This is just a question. This is a type of questions to erase by using n. So it means that if you are using n over here to erase all bits in D0 except 0 to 3, means that this was 0 to 3. This is bit 0 to bit 3. If you want to erase the whole thing in D0, data register 0, you must have to mask it with 0. So you are going to end this value in data register, given data register is this one. Okay, and then you have to make it all 0. You must end it, because here is going to be ended, all 0 except the last 4 digit, which is bit 0 to bit 3. Then this is going to be the syntax, an immediate, a number. So you look at this one, this is an immediate. Okay, an immediate dot long, the size, and then the value here, this is the value just now. Okay, and then this is your effective address. In this case, this is the D0. Okay, so here on this particular example, this is a W size. W is the size is W, so you're going to take this for sorry, this is not the one. So this is D0 content relation. This is dot long, so you have to take all of it. Okay, this is all of it. Okay, now you have to make it in a binary, because when you want to do the logic instructions, you want to do the logic operations, you must convert it to binary numbers. You must convert it to binary. So A is equivalent to 1010, D is equivalent to 1101, 2 is equivalent to this one, B is equivalent to this one, so the rest of 0 is all for this one. So the question is asking, you have to erase all bits inside this register except bit 0 to 3. Bit 0 to 3 is this one. You know that for the AND operation, you can put all 0 to erase it. Then this one is going to be AND with F only for this particular one. This is F. So right now you're going to erase everything except the value of the last 4 bit. This is the one, because when you put all 1, it's going to copy back the value. Okay, this is the value. That's how they say is erase all the bits in D0 except B0 to 3. So this is an operation. So you can try in Easy68K. Just a very quick one. Okay, I just show you guys how to do it, and then you can try it by yourself. So this is the one. The value is and move.long hash $, 0000 b to the a, 0000 b to the a to d0. Okay, and then the operation is n immediate dot long, okay, $f to d0. Okay, is it correct? So there's a problem, or there's an error over here. N immediate dot long. Okay, that's not error. Okay, execute. So run one by one by trace. So this is going to put the value to d0, and then this is going to only have this a numbers to be n with this value, because this is only the one that it has the value, because the rest is all 0. So you're going to look at the result at dA. dA is going to be all 0, 0, 0, 0, and finally is going to be a. This is copied over. So this is a. The rest is all 0. Okay. Okay, so that's for the AND logic. Then logic OR. So OR instruction set certain bit in destination. Okay, so if you know that what if the bit is 1, then it will has the number 1 with the output. Remember that the table over here, if you have any value for OR is 1, then you can get the result is 1. Okay, so here, if the value is 1, when you OR it, it will set the bit in destination, means that it has to be 1 at the end. If you put 0, means the value will not change, because any value go to with 0, it will keep the same number. Okay, so the operation and the assembly syntax is nearly the same like just now. We have the OR, effective address, data register, effective address, and we have the OR immediate, which is the size and the value to the each effective address. Okay, the question is asking to have the bit 5 to 7 to be set. This is set means 1. So you are going to make it as 1. This is just how you want to ask the questions. So this is going to be, you have to set all bit 5 to 7, means that you have to OR it with number 1. OR it with number 1, okay. D0 contents of this value, so the operation is, you can use W over here. You can see that this is the contents A to D. So bit 5 to bit 7 is where this is bit 0 to 3. This is 4, 5, 6, 7. This is 4, 5, 6, 7. This is 4 to 7. So right now, this is 8, 12. Okay, so the contents in this register, the locations of the bit 5 to 7 is over here. So D is this one, 2 is this one, 2 is this one, A is this one. So what you can do is you need to set, okay, bit 5 to 7 means if you change all this one to binary, you are going to set it, means you have to put 1 and make it OR immediate with this one. So you have to put only 1 from bit 5 to bit 7 here. So the contents of the value, this is the one 0, this is 0, this is E, and this is 0. D0 is the top one. You can see that this is the one that I showed you just now. So once you have this one, you are going to make it OR. You have to do the OR operation. So whatever number that you have, number 1 will have the result once, because this is must set bit 5 to 7. So you can see that if you put all this one 1, you can get all the result here. The rest, when you put 0, it will copy back the values in the bit in the first place, the original one. Okay, so this is the value here, and then you have the value after the operation. So you must know that the contents is before this one, and the content is after this one. Okay, this is OR. Okay, let's move on. Exclusive OR instructions complement certain bit in destination. So this is another one which is exclusive OR. So when you put one for the exclusive OR, it's going to complement. Complement means if you have 0, the complement will be 1. Okay, if you have 1, the complement will be 0. Okay, so if you put the value 0 to do the exclusive OR operation, it will keep the original bit in destination. Just now for the OR operation, if you want to keep, you also need to use 0. But for AND operation, you put 0, it will erase the bit. You are going to clear the bit. Okay, so you can try to look at the AND exclusive OR operation. So in this example, it wants to complement bit 8 to bit 15, bit 8 to bit 15. So this is going to be bit 0 to 3, 4, 5, 6, 7, 4 to 7, 8, 9, 11, 12, 8 to 12, and then this is 13, 14, 15, 16. So this is bit 16 at the end. Okay, now you're going to look at the complement bit 8 to bit 15. So the location will be 0 to 3. This is 15, 13, 14. Hold on, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is 11, sorry. 12, 13, 14, 15. Okay, 8 to 15. 8 to 15 is this one. You want to do the complement. So you are going to use the exclusive OR. And then this is the value. Complement means all 1 here. So in exclusive OR operation, if you see 0, 1, it will complement the value here. 0, 1. Okay, 0, 1. 0, 1 is 1. 1, 1, you are going to complement this value. 0, 1, you are going to complement the value. You are going to complement this value. So you can see that the opposite value is the results after you do the exclusive OR operation here. Okay, you can try to do the in Z60AK, you can get the same results for this one. Okay, and the last one is the NOT. NOT is very simple. Directly, whatever that you put, it must have the opposite value is the output. So the operation is just NOT here. Complement, that's why I say just a complement means that you put 1, the result will be 0. If the input is 0, the result will be 1. Very simple. So complement byte in D0, byte and byte is what? Only 8 bit. D0 contains this value. So bit is only this one. Okay, then you can see that this is D and this is 2. So the operation is not B, D0. So whatever value that here, you have to make it the complement, which is the opposite value, 1 to 0, 0 to 1. So finally, you can get this value. Firstly is A, 2 to D, and now the answer is A to D2. So this is going to be D, and this is going to be 2. So that is the operations of the logic. It's for the Boolean instructions. This is the logic operation, which is you have the AND, you have the OR, you have the exclusive OR, and you have the NOT operation. So you just need to look at the syntax, how it is written. Here you can see that this is an example of not B, the value for the data register, and you can see that these are the syntax for the rest of the Boolean instructions for the logics. Okay, let's move on. Now we are going to learn about the shift and rotate instructions. This is going to be a long one, so it's going to be eight syntax that you need to learn. Okay, the first one, we are going to learn about the arithmetic shift left, then logical shift left, rotate left with extend. Okay, arithmetic shift left, shift right, sorry, logical shift right, rotate right, rotate through with rotate right with extend. So this if I have the questions here, I will give you a table. So you just need to read the table how it's going to work. So in this syntax, right, you are going to shift and rotate the bit. So the size will be again byte, word and long word, and only data registers and memory locations may be used as the operands. Okay, only these two, the operand, okay, can be used as the operand. Address register direct cannot be used, so this is going to be only two data registers and memory locations. When a data register is to be shifted or rotated, a count must be supplied that specifies the numbers of bits to shift or rotate. So it is going to tell you guys how many times you need to shift or you need to rotate. Okay, let's look at the example. This is not going to be, this is just the syntax, but it's okay, we just go through directly the syntax, how it works. Okay, before we go to the syntax, you need to understand how this table is, how to interpret this table. So just now we have 8 syntax, right? From the arithmetic shift left up to rotate right with extend. So this is a table: arithmetic shift left, arithmetic shift right, logical shift left, and logical shift right. So the data can be the operand. This is the syntax here, and the operand size can be word, byte, or long word. And you have to understand how this one is being interpreted. You need to understand this one. Okay, the first one, you have to understand X and C. So if you go back to the last lecture, X and C are the register, are the bit in the status register. C is for carry, X is for extend. So remember that these are the 2 bits under the status register which are going to be used in this operation. So it means that the first one, arithmetic shift left, once this syntax is applied, so how many times? If only one times, this is a process, a 0 will be shifted here and the rest will be shifted to, and the MSB here will be shifted to this 2 bit at the status register. Same goes to this one. You have to understand how the arrow, where's the arrow, where's the location. So this is, you have to learn, this is the MSB, this is the LSB. Okay, same goes to this one. So when you have this one, you know that you must put 0. You have to shift to the left, or this one shift to the right. Okay, same goes to this one. This is rotate. Rotate is a bit different. Shift is direct. Shift is either you are going to shift it to the left or you're going to shift it to the right. This is the arrow that you need to look at and understand it. Okay, this is the arrow. And then you have the rotate. You have to look at, when you look at the rotate, right now, the rotate, you can see that the rotation could be like this. Once there is no extra numbers going in, it will use the same number, but you can see that it's going to be rotating. So rotating, how many times is up to the question. So this is X and C, still the bits in the status register, and this is going to be your MSB and LSB. Okay, this is the concept. So you have to look again, keep on looking on the table and understand how the arrow works. Where's the directions of the bits going when you do the shifting and when you do the rotating. Okay, let's look at the first one. The first one is arithmetic shift left, and we're going to also look at the arithmetic shift right. So this is going to be the same, nearly the same. Okay, what happened is, this is the table just now telling you guys that if you have the instruction of arithmetic shift left, if it's being done once, you are going to have a value 0, push to this value location, and the rest of the contents will be moved to here, and the MSB will be copied to X and C. So for the arithmetic shift right, this value, for example 0, will be pushed again. So the rest will be pushed, go out here to the right one, and the LSB will be going to be copied to X and C. Okay. Let's look at the example here. Okay, I'm going to open up the Word file for a while. Hold on. Okay. The example now is D1 is given this value. Okay, you have to perform an arithmetic shift right in byte size only, byte only this one. Okay, byte size, byte only this one. Okay, how many times? 2 times at D1. Shift rotate byte size 2 times at data 1 register. Data D1 register. Okay, D1 register. D1 is given this one. F0 is the back of the byte size. Byte size, yes, correct. So you're going to arithmetic shift right for 2 times. Okay, let's look at the arithmetic shift right concept. Arithmetic shift right means you have to put the value here, MSB, okay, then push the rest. Okay, let's try. Here you have the F0. F0 means you have, in byte size, you have the byte, right? Size is F0, $sign. You have to convert it to binary. This is going to be 1, 1, 1, 1, 0, 0, 0, 0. Okay, so this is the binary. So what you need to do is arithmetic shift right. Arithmetic shift right. Okay, so means that you are going to have the first MSB value to be used to shift the rest for 2 times. Okay, now this one will be used to shift, insert and shift. So right now the first value for LSB is 1 and the rest will be moved to the next one. 0, 0, 0. And then the MSB here, okay, the MSB here is going to be copied to X and C. Okay, this is the first arithmetic shift right, the first one. Then you have to do again the second time because the question is you have to do it twice. Shift rotate. You see that this is going to be copied. The MSB is going to be copied at C, X and C. Okay, let's look at the result for the second one. Okay, second one, arithmetic shift right. You have to do again the same one here. So take another blue color. So this is going to be push again. So just now we have the blue color, sorry, the green color here, and then you have the red color for the rest. 1, we have 4 what? 2, 3, 4, 0, 0. The MSB here will be copied to X and C. So after 2 times is completed because the question is asking you only to shift right for 2 times. Okay, now the answer, this was going to be F. This is going to be what? 10, is it? No, 10. This is 12. 12 is C. Yeah, correct. This is C. So the result for the byte will be changed to FC after you do the arithmetic shift right in byte size for 2 times. Okay? You can try to have the result to be put in the example here in the Easy68K. So let's try to do this one to D1 here. 1, 2, 3, 4, 5, 6, F0. This is going to be to D1. Then you're going to use the arithmetic shift right byte size, right? 2 times at D1. Okay, let's run it. Execute this one. So let's run the first one. This is going to be inserting the whole D1 contents. This is going to do the arithmetic shift right in byte size for 2 times at D1. So look at the results over here. So this is going to be FC and your X and V is copied 0, 0. Okay, this is the status register. There's no change. Okay, let's move on. Next one. This is example 2 is arithmetic shift left dot byte 2 times again at D1. Okay, D1 is given, this one F0 again. So let's try to look again on the example. Okay, the first one is this one F0. So, okay, this one. You're going to do the arithmetic shift left, right? Yeah, arithmetic shift left byte to D1. So D1 is this one for the byte size. So what you need to do is you have to put 0 push here to the LSB, and the rest will be shifted up. And the MSB will be going to be copied to X and C. So let's do it once. The first shift, 0 going in, and you're going to push the rest, and the value now is 0, 0, 0, 0, 1, 1, 1. Your X and C is equivalent to the MSB here is 1, 1. So this is the first shifted left. Okay, let's look at the second one. We have to shift again because this is a 2-time shifting. So we are going to push again a 0. Okay, now you have the 0 over here. Then you have the old 0 just now. Then you have the red color, all 0. 4 zeros. 3, 4. And 1, 1 here. And your X and C is equivalent to the value here. Okay, so this is the final one. This is going to be C. This is going to be 0. So it is the same with the results over here. Okay, so you need to understand how this table is telling you guys. You need to know how to interpret, how to read this. So this is, once you understand how to read this table, there is no problem at all for you to learn for the rest of the process on the rotation. Okay, just now we have 2 completed for this one. Just now we have the ASL and ASR. Okay, now we have to go to LSL and LSR. Okay, let's look at the example for the logical shift left. So this is the method how you're going to do logical shift left. Actually, this is nearly the same like this one just now. For the arithmetic shift left, it's nearly the same. For the logical shift right, you are going to put 0, push to the right, and you have this LSB going to be copied over to X and C. This is just a definition of what happened if you do the same thing for the operation. So we just need to understand how the operation works. Okay, let's look at the first one. D1 is given 1, 2, 3, 4, 5, 6, again F0. Now you have to do the logical shift right byte size 2 times D1. So F0 is given here. Logical shift right. Logical shift right. Okay. Logical shift right. Let's try to look at this one first. Logical shift right, you are going to push a 0 to the MSB, and the rest will be copied to X and C. So now it's very simple. Push 0 in. Your 0 will be here, and the rest of the original value will be here. So X and C is going to be 0. This is the first time. First shift. And the second shift, you have to put again the value, push 0 going in, so you have this value 0, and you're going to copy over the value for the last one just now. So 1, 2, 3, 4, 0, 0. X and C is still equivalent to 0. So the result is going to be what? This one is going to be 3 and C. So this is going to be 3. This is going to be C. So the answer is correct. You can try to validate with the Easy68K. You can get this result, and you have to check your X and C correct or not, because the final value which is over here I have all the same one, x and c is equivalent to 0. Okay, same goes to a logical shift left dot byte. So this is a value d1. Twice you have to do that one again. So again you have to shift from 0 here at the back, okay, at the LSB. So let's try. Okay, let's try here. Okay, what you need to do is you need to shift a 0 outside, go in. So the 0 will be here, and you have the rest of the value here, 1, 1, 1. And you're going to copy over x and c. The first one here is going to be here, 1. Okay, and then you're going to use the second one. Okay, 0, go inside again. So you have this number value 0. This is 0, 0, 0. 0, 0, and 1, 1. This one is going to be copied over to x and c. So let's try this one because you want to see the result of x and c, right? So let's try logical shift right. Oh, this is FF. This is not F0, this is FF. So FF might be different, the result. Okay, let's try to look at the FF. Okay, it's okay. This is for F0. So let's try FF. For the case of FF, you have to do the same one, same problem here is FF. So all is going to be 1, 1, 1, 1, 1. So the first 0 is going to be pushed to this one, and the answer, the rest will be all copied here, and your x and c is equivalent to 1. And then you have the second one, 0 shifted here, you have 0 here, then you have this, the one that previous one that you have, then finally the rest is this one. So this is F, this is C. So the answer is FC. Is it correct? Yes, it's FC. So I just want to show you guys how it works in Easy68K. So this one should be FF. Okay. Now LSLB 2 times to D1. Okay, this operation just go to move to D1 over here. This is, you have to do it shifted left shift, logical shift left 2 times for D1. Look at the value for the x and c, still 0. So once I click this value, once I click this execution button, it will complete the whole operation, not one by one. It is going to complete the whole thing. So can you see the result? Now you can see now your x and c is copying the MSB for the value in D1 just now. So my calculation is correct in this word. This is the method how we're going to do based on the table. Okay, so this is how we're going to do. For the rotate, okay, rotate, you can see that this is the method how it works. Okay, this is the method how it works. So C and C here still the you can see, sorry, the rotate will be the rotation will be like this. When you do the rotation once, it's going to have the value here going to be put at the back here and then push over there. So it's a rotation, and also the MSB will be copied to C. C still the carry bit in the status register. Same goes to this one. So you have the rotate left and rotate right, and then we have the rotate XL, rotate left through X, and rotate right through X. Okay, what I'm going to ask you is you're going to do this one by yourself for the rotate left and rotate right. I'm going to give you the questions at the assessment, but I'm going to teach you on this one, the rotate left through X and rotate right through X. Okay, what does it mean? Rotate the operand to the left through X. You can see X is now the place where you have to copy first the value before you go in. So the first step is going to be here. The next one is going to be pushed next to this one. Okay. Same goes to this one. You have to look at the table. This is how it works. is going to rotate, go to X first, through X, and then it will go to the register or the contents of the where you want to shift, you want to rotate. So let's try on the example here. Okay, D1 is equivalent to A 1 2 3 4 5 6 A1. Okay, rotate through X, right, in byte size 2 times D1. So now you have D1. A new one just now, D1 is A1. For the byte size, okay, D1 is equivalent to this value, and the byte size is A1. Okay, A is going to be 1 0 1 0. 1 is going to be 0 0 0 1. So this is the binary, this is hexa, this is a binary numbers. So you need to do rotate through X. Okay, rotate through X at D1 bytes. Okay, so in this question, the contents of X is equivalent to 0, initial value. So X initial value is going to be 0. There's no value at the X bit at the status register. So you need to do what? You need to do the rotation twice. So the first one for the LSB will be going to move to X, and the contents at X will be moved to the register. So now let's look at the results here. Okay, this is going to be moved to X. Okay, this is going to move to X. Okay, the content X will be moved to this one. Okay, the answer will be 0 1. You have to rotate over there. 0 1 0 0 0 1, and now your X is equivalent to this value 1. This is the first rotation, so we have to do it once again. Okay, so this is going to be go to X again, and the contents right now, just now, okay, sorry, so we have to do again the rotation through X. Now your X is going to be is going to be 1. Now you are going to push this value. Is it correct, this one? Sorry, this is not 0, this is 0, because the content is 1 0 1 0 0 0 0, so this is 0, and the X is equivalent to 1. Now you have to do it once again. Okay, this 0 is going to be copied to X, and the content here will be rotated to here. So right now, this is going to be the results. 0 1 0 0, sorry, this is 0 0 1 0 1. Okay, 0 1 0 1 0 0 0. Now your X is equivalent to 0, because this is the one that have been replaced here. So the answer is this one. Is it correct? This is going to be A. This is going to be 8. The answer is A8, and the final X value will be 0, because the last one is this one. Okay, same goes to this one. You have to try, okay, one by one. A1 here, and then you have to do rotate twice through X again, and the condition value, initial value for the X is given as 0. So now you can see that the MSB is being shifted, okay, shifted to the copy, whereas the contents of the MSB here is also copied to X, waiting to go in again to the register again. Okay, you have to do it one by one. So this is A1 initially. let's try to look at the answer. A1 again. Okay, x is equivalent to 0. X is equivalent to 0. So the rotation will be from the MSB, do it here, go to X, and then the value will be copied to C, and the rest is going to be pushed, copy first here, and that's going to be pushed over there. So right now your C is still 0, so let's try to do the first rotation. Okay, this one will be copied to C, and this one will be copied to X, and the contents of X will be pushed to this register again. So the result will be, let's try to have result here. So this one going to be 0, 1, 0, 0, 0, 0, 1, 0. So your C now is going to be 1. Your X now is also going to be 1, because you already copied the first one just now. So let's look at the second rotation. So the first MSB is 0 here, so it's going to go here. Now your C is equivalent to 0. Is going through the X. Your X now is going to be 0. The content here must be put inside the register. So the content here must be put to the register. So now you push here 1. The rest will copy back the value above 1, 0, 1, 2, 3, 4. So this is the result. After 2 times rotations through X, okay, you have the results here. This is going to be 4. This is going to be 9. Is it 49? Oh, sorry, 85. So I think I have a problem here. A1 here, 85. So let's try have 85. Okay, this is going here 1, and the result here 1. Oh, this one I'm wrong. Okay, sorry. Okay, just now the result for your X. Okay, let's do it again. Your X and C now is 0. Okay, X and C now is 0. X, C is equal to 0. X is equal to 0. So how is it going to work? This is going to be shifted in, put in over there, and then wherever your MSB is going to be copied and also go to X and C. Okay, copied over X and C. So here, what happened now, you're going to push here, your C is equivalent to 1, also copy to X, X is equivalent to 1. The content here is going to be shifted in, and now you have the original value, 1, 0. So this is a first rotation, and then you have the second rotation. Go here, so C is equivalent to 0. C is also equivalent to X. X is equivalent to 0, and this one is going to be shift to here. So you have the result here 1, and the rest is 0, 1, 0, 0, 0, 0, 1. So this is the answer. This is going to be 8. This is going to be 5. Yeah, I got the same answer. So the most important thing that is you need to know, you need to understand this table. Look at the table. and try to finalize how the rotation or the shift process completes. You have to look at the arrow. You have to understand how it works. You have to know where is the MSB, where is the LSB. Okay, so no matter what, if I have this question, you can just simply look at the table. I have no issues, because you need to interpret it, how the concept looks like, and you need to answer based on the rotation itself. Okay, on or the shifting. Okay, so is there anything else over here? Okay, okay, that's for the first sections. You can try to answer the first quiz sections over there, and I'm going to do the second lecture for the bit change to bit test in the next lecture. Okay, thank you very much on that.